What are some of the microstructures that build up the world around you? Have you ever wondered what your bones look like up close? What about concrete, or soil, or rocks, or even wood? To study these microstructures, we need a machine that allows us to see the fine details that comprise the world around us. We use a machine called the XRay Micro Computed Tomography Scanner. This machine is a tool that uses X-rays to see inside of a material. And X-rays have a wavelength of 0.01 to 10, which is much smaller than the human eye can detect, and that's how we can see inside these materials. Have you gone to emergency care to get an X-ray or CAT scan before because you broke your bone? It's the same idea, but instead of a 2D flat image of your bone, we can obtain a 3D volumetric representation of your bone. This specific machine can do very fast scans while capturing important levels of detail about a material, and it can be used to scan a range of sizes of materials. To understand the significance of seeing these structures so closely, let's look at a few examples. The loading strength and resiliency of a material is closely tied to the microstructures that make up the material. The microstructure of concrete plays a critical role in resistance to freeze-thaw cycles. We purposely place extra air bubbles in concrete to improve the ability of water to freeze into larger pores and reduce internal stress buildup. Another example is wood. All trees grow radially outward, so the microstructure varies in the different directions. The microstructure is stronger if loaded vertically. Because of this, wood used for construction is cut perpendicular to the ring growth. After wood is cut for construction, it has to be dried before it can be used for construction. If the wood is dried too quickly at high temperatures, the material can become brittle and cracks form, which completely alters the microstructure. Hence, the method for drying is very important to ensure the microstructure is not altered in a way that compromises the structural integrity of the material when used in construction purposes. Another example is asphalt concrete, which is used on the surface of roadways. The most important aspect of asphalt concrete is achieving the correct density. This is achieved using rollers immediately after placing the asphalt so the microstructure becomes denser. Many people have heard of osteoporosis, which is the gradual reduction of calcium which comprises our bones. As the calcium material reduces, the void space, we call this porosity, becomes larger. Larger void space in a bone makes them more fragile or weaker and can change how resistant a bone is to breaking under different conditions. For example, jumping and landing abruptly or falling and breaking your wrist. The X-ray micro-CT machine allows us to understand the materials that build up the world around us and see how these structures form, break down, and evolve over time. By observing the evolution of the microstructures, we are learning how to design and build more adaptable structures for our ever-changing world.